We visited a farmer. He said, oh, you can go and pick as much capsicum as you want from the field. And then I asked, are you going to harvest this? And he said, well, no. All this crop will be plowed tomorrow. The cost that I have in the pickers supersedes what I would get for the crop in the supermarket. This really motivated us to look at, well, if we can actually reduce some of these costs and prevent some of the food wastage and help the farmers to have a more profitable enterprise, that would be a good motivation for our project. When we started working on this, we looked at the progress that other groups have done globally and the progress they reported, and it was actually very modest. So what we did is we concentrated on what we thought they were the key bottlenecks. One of them was a perception, how the robot can see the fruit in the bush, and the other one is the actual picking tool.
We've been trying to get our team together to set up our vision system or our perception system. He's trying to do it in the real world, so he's got all these challenges of the unstructured parts of the plant to have to detect capsicums in, figure out where the capsicum is in the plant, and he does that by fitting what we call a geometry model to the capsicum, and that gives you a location attached to it using a custom built tool that we've done, and then also detach it from the plant.
It was a fairly tricky task to pick sweet peppers in a greenhouse environment where every piece of fruit's a different shape. They can be hidden by leaves and behind branches, so it's a challenging task to design computer algorithms and grippers that can grab these pieces of fruit and cut them from the plant.
At the moment, our prototype is working very well in protected environments. We're trying to extend it to other crops, such as mangoes, apples, avocados, and strawberries. By having a robot, you can do selective harvesting. So therefore, you can harvest your crop at the optimal time window all the time at different stages. On our first trials, we have a success rate of about 90%, which was remarkable for the short amount of time in which we've been working the project.
Harvey has so much potential. If he can be autonomously navigating down crop rows and harvesting capsicums 24/7, then the farmers will just benefit from that greatly. There will be lower risk and also better profit as well. That's a really exciting thing.
We are seeking investment to automate several aspects of it, and again having a sustained trial in a real cropping environment to look at the benefits that this could bring to the farmers.
Returning this technology to the farmers would really be beneficial to Queensland and to Australia and maybe to the world.
To build the first sweet pepper harvesting robot, that was the goal of the Sweeper project. Increasing the efficiency and reducing labour dependence will ensure Europe's high-tech greenhouse food production yields and competitiveness. The robot is an assembly of an autonomous mobile platform with a robotic arm holding an end effector for fruit harvesting. The robotic arm with the end effector scans the crop for mature peppers. The camera operates completely independently from surrounding light conditions. It gives color images and a distance map. This information is used for pepper detection, localization, and maturity classification. Peppers are scanned by looking slightly upwards. By observing the bottom part of the pepper, maturity can easily be detected. The robot was trained to find obstacles like leaves and stems in the images. To speed up the training work, a simulated artificial pepper crop model and a deep learning network was used. After detection, the pepper location is used to perform a path planning for the robotic arm. This can be a complex trajectory, since the space in which the robot arm may move is very limited. The robotic arm employs visual servo control to reach the peduncle of the peppers on target. For this, it takes images from several sides. The arm approaches the pepper in such a direction that the stem is always to the backside of the pepper. The small cutting tool is positioned just above the pepper and cuts the peduncle while the cutting tool is moved downwards. After cutting, the pepper falls downwards into the fingers of the pepper catching device and is moved towards the pepper bin by the robotic arm. A conveyor belt will be added to the robot in order to convey harvested peppers to a standard pepper trolley. Multiple robots and trolleys will be part of a fully automated post-harvest logistics management system. The robot will exploit its harvesting skills in full in a single stem row cropping system. The most suitable yellow existing pepper variety was used during the test. The Sweeper project results will serve as input for the development of a new, fully optimized and automated sweet pepper production system for the greenhouse horticultural sector. The automatic harvester will contribute to solve some of today's major grower issues, such as labour costs, labour availability, food safety and quality.